Hey everybody, it's Todd Francis, and I wanted to give this video to as we finish up Chapter 8. Um, as you remember, right before spring break, one of the things that I was emphasizing in Chapter 8, in the calculation of the mole, was the conversion from atoms to moles, and that's where you use Avogadro's number, and then from moles to grams, and that's where you use the molar mass. You have the periodic table that will give you the molar mass for each of the elements. If you have a compound, you add up the masses for each element in the compound, and that gives you the molar mass for that compound. Well, one of the things we can do with the molar mass of the compound is we can find the percent of each element in that particular compound. And that's what you see at the start of section 8.6 in calculating this mass percent. And look at this calculation here. So if I want to find the percent, and they call it a fraction, but a percent, same thing, for an element in a compound, look at where we're going to divide here. We'll take the mass of the element that's in the compound, we'll divide it by the molar mass of the compound itself. So for the example, they're using ethanol, the CH2H5OH. What they need to determine at the start is the molar mass for ethanol. And again, look at how they add this up. From that molar mass then, if we want to find the percent carbon, we'll take this mass of carbon, which is the 24.02, and we'll divide it by 46.07. And we'll do the same thing for the hydrogen and the oxygen. The mass of the hydrogen, we'll take the 6.048, divided by the 46.07, and the same for the oxygen. The one way that you can check to make sure your calculations are right, the percentages, they'll add up to 100. And that's what you see here on the next slide. Morphine, very nice pain reliever. And you see the chemical formula for morphine. So the first thing that we have to do is we have to determine the mass, the molar mass of the morphine. And that's what you see on the bottom part of the fraction here. The 17 carbons, the 19 hydrogens, the nitrogen, the three oxygens. There's the molar mass. And we're going to divide it by the total mass of the carbon in the compound. So again, very similar to what you see in this example. And you can see morphine, 71.6% carbon. Here you've got 100 gram samples, and what you would do with each of these, if you're looking for percent oxygen, is you would set up that same problem. So if we're working with water, we'll take the total mass of oxygen in water divided by its molar mass. And the same thing for the N2O, the C3H6O2, and the CO2. And you would do, and again, go back to this example here. Just substitute in water and add up the masses of the hydrogen, oxygen. Substitute in the carbon dioxide, the mass of the carbon and the oxygen to solve that. And you see the ranking for this. The last part of this chapter looks at how we can determine the formulas of a compound. The empirical formula, as you can see here, expresses the smallest whole number ratio. A lot of times we call it the simplest formula for the compound. Our molecular formula, when we talked about compounds, that's the formula we've always discussed. So benzene has this molecular formula C6H6, but we can make it simpler by dividing each by 6. That's where we see the empirical formula for CH. So what we're going to do is we'll look through the steps at how we can determine the empirical formula for the compound. And here's the great thing about this. You're following the same steps each time. It doesn't matter what the compound is. If you're given a percentage, look what they're saying. Hey, we're going to assume that we have 100 grams of the compound. Percentages should add up to 100. So look at what they're saying here. We've got a compound with carbon and hydrogen, 83.6% carbon by mass. So if I have 100 grams, that means I have 83.65 grams of carbon. And the hydrogen falls from that. The next step, we're going to take each of those gram amounts, convert them to moles. And again, we've seen this calculation. The molar mass comes from our periodic table. Now that we have a mole amount, look what it says. Divide the number of moles for each element by the smallest number. So again, compare our two mole amounts here. We had 6.965, 16.22. So we're going to divide each of these by the 6.965. And that gives us our number. Now, ideally, these numbers will be whole. But we've got a fraction here. We've got a decimal amount. And subscripts are not decimal amounts. So, look what they tell us to do. If we have this decimal, we'll multiply those numbers by the smallest integer to convert it all to a whole number. So we had 0.33. Hey, we're going to multiply that times 3. And again, but we also multiply the carbon by that too. And again, think about this. Hey, 0.33, we'll multiply it times 3. If our decimal was 0.5, you'd multiply it times 2. If the decimal was 0.25, multiply it times 4. And you see the empirical formula. So again, that's the simplest ratio for this particular compound. And the same thing here. Now they've done all this work. They've given us the answer to C3H5O2. So what we need to do, again, you've got the percentages. Assume you have a 100 gram sample. So that means you've got the 49.3 grams of carbon, 6.9 grams of hydrogen, 43.8 grams of oxygen. Convert each of those gram amounts to moles. Divide each of the mole amounts by the smallest of the mole amount. And then if you've got a decimal amount, multiply that by the number to make it a whole, and you get your empirical formula. To find the molecular formula, we need this empirical formula. But we also need one other piece of information. For that molecular formula, we also need the molar mass. The molar mass of the compound is going to be given to us. So in this case, this 86.2. So they went back to the example we saw earlier where our empirical formula was C3H7. And again, go back here. Look what this says. Molecular formula is equal to the empirical formula times N, where N is a whole number. So there's our molar mass, the C3H8. Again, the molar mass for the molecular formula is going to be given to you. Hey, we'll divide that times 2. And we end up getting our formula. In this case, C6H14. Again, you go back to the adipic acid example that we saw. There's our molecular formula. So find its molar mass. Add up the masses of the 3 carbons, the 5 hydrogens, the 2 oxygens. Take that number, take the 146 divided by whatever this molar mass is. You get that value of N. And then multiply each of these subscripts by that value. Okay, so I hope that helps you as you finish up this chapter. Good luck. If you have any questions, please contact me. I'll be happy to answer. Take care.